Assalamu alaikum warahmatullahi ta'ala barakatuh, ladies and gentlemen. Welcome back to another live stream. So please join my Discord server. You can find the link in the description, and let me share the link with my Discord server. Live. Yeah, I think all good now. So this is gonna be my third attempt at decoding a video using FFmpeg library using unsafe Rust. The first attempt we were using, the first live stream, we were using an outdated tutorial. The second one was more, I guess, modern, but still quite outdated and lacking in detail in like the first one. And also it didn't work, although I have tried my best to, you know, reconcile with the documentation and stuff, but it just didn't work at the end of the day. So in this third stream, we're just gonna follow this time the official example of FFmpeg, and we're basically just gonna go ahead and translate the C code into unsafe Rust code. And that's basically it, I think. And hopefully this time it would work and we can decode our first video. And we'll see where to go from there. So yeah, let me make sure everything is fine. Yep, seems all good to me. Okay, great. So let's get started. Let's go to the FFmpeg source code now. Source code, git repo, browse. Great. Okay. Let's go to doc, examples, and what's next? Demux decode. Not decode video, but demux decode. And let's go. So this is hopefully the example that I'm gonna follow and translate, and we're gonna see if it's gonna work by any chance. So yeah. All right, so I'm gonna put this, so just press dot to bring up the online editor here. Let's go. Nice. Great. Cool. So I'm gonna put this on the side of my second screen, and we're gonna try to translate this, the C code, into unsafe Rust. Hold on, let me pop out the chat. There you go. And there you go. Where's my second thing? There you go. But how to do this? All right, great. And yeah, all right, man, nice. So yeah, I have set it up now. The chat is also set up. Great. So let's go. Let's see where to start here. And in the second stream, I also got trapped in pre-abstraction, like premature abstraction. So this time I'm just gonna, you know, follow it, just everything inside the main function, just to make it work. So yeah, input file, video, output file, input, right. So let's see. So the first thing we have is AV format, open input file, open input file and allocate format context. And FMT context is, I believe, a global variable, maybe. Let's see, hold on a second. Yep, it is a global. This code is using a lot of global variables. That's crazy. Anyways, so they're all basically null, I think, other than the video decode context thing seems to be called audio deck context. That's super weird, like the variables are everywhere. Anyways, whatever. This is C. Alright, let me go to it anyways. So essentially what you do is, first of all, we need a pointer to AV format. So format context essentially. Okay. It's gonna be mutable. Well, hello Pipper Note. Welcome to the live stream. How is it going? Long time. Mutable. Mutable AV format context. Great. And then we're gonna go with null mute. Oops. So in the C code, they're basically doing it like this. They got a format context with a null as a null pointer, and then what they say is just AV format. Well, I'm gonna do all of this as unsafe. We're gonna have a lot of unsafe code. Right. There you go. And of course, by the way, I'm using anyhow an FFmpeg CS next, and anyhow just for making error handling a bit easier, basically. Sorry, I'm still recovering from my sickness, but anyways, so in safe, let format context. So what's up with this guy? All right. So let's see, format context. Yeah, AV format. Open input, and then here the PS. Here we're gonna give it format context, I believe. Format context. We're gonna give it a reference, I believe, to it. Correct. To format context. It's gonna be mutable reference now, I think. And then the URL is the actual source file name. So source file name, and then which is a const char, basically a C string, and then a AV input format, which is null. So null, since it's gonna detect it. We want FFmpeg to detect the file name. And of course, by the way, I have a little demo video here. It's inside the res folder, video MP4. So yeah, basically. Let's see, here we gotta say null, I think. Let's see, null, yeah, and null mute here. Great. So what's up with this? Canabara mutable, make format mutable. Is this your default streaming time? Yes. I don't stream at the day, I stream at night, basically. Right. Source file name. So for source file name, I'm just gonna hard code it. We're gonna say C stir from bytes with null, I guess. With null and checked. I see. With null in checked, and we're just gonna go with video dot res/video.mp4, and let's make sure to add the null byte. And of course, this should be bytes because the default Rust string is actually UTF, like it's Unicode essentially, UTF-8. But anyways, great. So this should be as BTR, and now we're good. We got this out of the way, and now this AV format thing should be, if it's less than 0, then it's a problem. So let's assert that this is greater than or equal to 0. Let's go. Oops. Let's go. Nice. Let's make sure that this at least compiles even. There you go. All good. Nice. Let's go to the next one. I'm not gonna care about closing stuff just yet. Let's just go with it. Just make it work for now. I don't care about correctness. AV format open input. Now AV format find stream info. Okay, so assert that AV format find stream info. Here we got mutable AV format context, so yeah, and here null mute, I believe, right? Or no? Yep. And we're gonna make sure that this is greater than or equal to 0. And I think that's it for finding the stream info. It's gonna put the stream info inside the format context. We're gonna check the documentation later on. Right now I'm just copying it, basically. Translating it, should I say, into unsafe Rust. Anyways, so I think this should all be good now too. Great. Now we gotta open a codec context with AV media type video. Okay, great. Let's see. If, well, let's see this. Hold on. Greater than or equal to 0. But what happens otherwise, though? Oh, interesting. Open codec context video stream index video CTX FMT CTX. What is that? Okay, let's see. So if open codec what? Oh, it's a function. It's another function. Okay, so let's implement this function. Let me try to find it. There you go. Great. So it's an actual function. All right, let's see. So this function, what it does. Honestly, I just like to make it inline. Yeah, let's just do it inline. Honestly, let's not bother with that. Let's not bother with that, right? Fine. So find stream info. Great. What's next? Let's see. So we got return stream index AV stream st AV codec. Oh my god, it's not even C code, it's also like legacy C code, you know, where you have like all the variables all the variable declaration at the start, and it's crazy. But anyways, ret AV find best stream. Okay, and what you do with that ret, if ret less than 0, you got an error. Okay, else you're good. Okay, great. So let's do that. Assert that let's see, AV find best stream. Here we pass it the format context, and then the type. The type is going to be, in our case, we're interested into video type. So video, because, you know, like MP4 is basically a container. It contains multiple streams essentially. Like MP4 isn't actually a video format, it's just a container, just like MP3, etc., etc. There's a lot of containers out there. But essentially, a container could contain like multiple video streams, audio streams, subtitle streams, etc., etc. As you can see, there's audio, data, attachment, NB, subtitle, and known video. So what I wanted to say again. Whoa, G Gearing, wa alaikum assalam. How is it going? Oh, good, thanks. Right. So yeah, we're only interested for now into video. We just want something that works at this point. Greater than or equal to 0. Great. And this function takes 6 arguments. What a great thing. Wanted stream NB. I guess how much streams we want, or what? AV find best stream. It just said -1. I would guess -1 is basically figure it out yourself, I guess. And related stream, I'm not sure. We're gonna check documentation, as I said, later on to understand this stuff. But for now, let's just go with it. And here null mute in our case. In C, you don't care if a pointer is mutable or not mutable. In Rust, you do. Flags cint 0. Okay, so that should find the best stream. And where it does put the information, I would guess in format context. Yeah, I guess so. I believe so. So let's see if we just debug this for a second. Oops, what's happened? Yo, what? Really? Why it doesn't debug? Let me relaunch my... What? Okay, crazy stuff. For some reason, when you put it in an empty line, it doesn't work. Anyway, crazy stuff. Anyways, so AV format find stream info. Find stream info. I guess something have changed there, maybe. Anyways, and then AV find best stream. Oh. Let's say let x whatever. This looks initialized to me. Oh well, it actually looks all initialized. Which interesting. Why that is the case? Let me see if this actually works. Here we got format context equal to null, but then once you say AV format open input, the format context gets allocated and you get number of streams too and stuff, which is good. Okay, I don't know. Anyway, let's just keep going. Let's not waste time for now. Alright, so AV find best stream. What's next? I guess AV find decoder. AV find best stream. AV find decoder. And here we got stream index equal ret. Return. Okay. So this gives us back a stream actually. Well, a stream index, I believe. Yeah, stream index. Alright, stream index. Yes, equal to this. It's a cint. Alright, great. What's next? And here we're just gonna assert that it's actually greater than or equal to 0. Otherwise, it is it couldn't basically find the stream. It couldn't find the best video stream. Alright, great. Now we can actually get the stream itself by saying format context dot streams. But the problem with this is that AV format context is a raw pointer which we cannot access directly. To access it directly, we have to dereference it first, because in Rust we don't have that, you know, operator like this, like in C and C++. You have to do it this way, and this, and then you could do something like this. But instead of doing it this way, honestly, I'm gonna turn this format context into a reference instead of a pointer, because right now we know for sure that it's actually valid. So how are we gonna do that? Well, after open input, yeah, that should go ahead and allocate it for us. And what we're gonna do is let mutable format. So we're just gonna shadow that variable, and we're gonna say format context dot, well, as we know that it's for sure not null, we could just do this, like we could dereference it, but then take the reference again. And now, and yeah, here we need it mutable. And with this, we have actually turned it from a raw pointer, raw mutable pointer, to a mutable reference, which of course a mutable reference cannot be null essentially. And you can access it directly, the compiler does the dereference for you automatically for a reference. So that's nice. Great. And we don't need the mutable actually anymore, because we need it here just so we can write the new format context that we have allocated. In this case, we don't anymore. We're not going to change the pointer anymore, so that's fine. At least for now. Though later on, maybe when we're going to free it, it's probably going to set it to null or something, so we're going to need that anyways. So that's basically it. Now what I could say is format context AV, yeah, stream is equal to format context, and directly I could say dot streams. The problem though with this is that streams is a double pointer, double mutable pointer. So like mutable pointer to a mutable pointer. The thing is, the problem about this, you cannot really index into this directly. Rust wouldn't allow you, because that's a big problem. Because like this alone doesn't really give us any information about the length of that array of pointers, right? Because this is an array of pointers in C, but in C it doesn't care, like you just do your thing. But in this case, format context gives us another variable called nb streams. Okay, so now we have the pointer to the array, and we have the number of items in that array. Well, we could turn it into Rust slice. So let's go ahead and do that. So instead of doing this, we could say std slice from raw parts, and here we give it the data pointer, which is, in this case, it's gonna be format context dot streams, and the length is format context dot nb streams. So in Rust, instead of having one variable describing the point, like having the pointer, and one variable in the other west, or like one in the east and the other in the west, what you got is like in Rust we do this using a slice, like both are in the same thing called a slice. Here this is a u32 or a cint. We should cast it to usize first, because it's a size, and there you go. Right now we turn this double raw pointers into a slice of raw pointers through these two variables. Great. Now this is the first part. The second part is that this is now still a raw pointer here. We'd like to turn it maybe into into raw, not raw, well, it's raw pointers, we'd like to turn it into references. Let's see, yeah, let's map this into, so it was mutable AV stream, right? Okay, so we know for sure that it's valid, so we could just let's just say this map stream, right, string mutable AV stream is not an iterator. Okay, let's turn that into an iterator and let's go. Now, one thing that a lot of people actually does wrong when it comes to this is that they always say collect when they're done with it, which is wrong. You only collect when you actually need the vector. Right now, I'm just gonna keep it as a lazy map, and when I want to, well, honestly, we're gonna see about that. Well, let's see. So in this case, we're gonna need, let's see, stream equal FMT context. So yeah, we have a stream index, so we could use that to get the stream that we want in this case. So I'm just gonna say, well, honestly, we don't even need an iterator in this case, honestly. Yeah, fine. Let's just, I don't care about streams right now. I just care about one stream, so let's just do it directly. It's not overcomplicated. And here I'm just gonna say stream index, honestly. Okay, let's turn this into usize so it doesn't pose for us problems like this anymore. And I see. It's saying right now comparison is useless to type limits. Yeah, makes sense. We cannot really do that just yet, right? So yeah, fine. Let's just say as usize here. Great. Because we know for sure that after this assert that it's for sure it's greater than or equal to 0. Okay, fine. Anyways, so now we got our video stream. Great. Now what's up? Let's try this. Just gonna do something here. I don't know, just something so we could breakpoint this video stream. There you go. And the video stream. Oops, what is going on here? Super weird. Codec parameter. Yeah, it's very weird. Seems initialized to me. But anyways, whatever. Let's just go with it. I have no clue. Anyway, analog context. So the next thing is we get a AV codec find decoder. Let video decoder is equal to AV codec find decoder, and here we give it mutable stream. Well, by the way, this is still like a mutable AV stream, but I know for sure that it cannot be null, so I could just say this. Great. And here what I'm gonna say is video stream dot codec par. Though codec par is it, what is it? Is a pointer or what? Yeah, it is a pointer, so I gotta dereference it then first. So okay, let's do that, and let's say codec ID here. Alright, that's the video decoder. Find decoder, codec ID. If not dec, printf failed to find codec. AV get media type string. So basically find decoder could be null, so I should check, because if it's null, basically I think it have failed to find the codec essentially. So what I'm gonna say in Rust, I'm just gonna say as ref just like that. And this would give me an option. So if it's null, it's going to give me none. If it's not null, it's going to give me some reference, you know. And in my case, I'm just gonna like basically throw like crash essentially when that happens. So here in my main function, I'm just gonna go with an anyhow error results. Right, and finally when we're all done, we're gonna say okay. Great, so I could use this guy right here, but this is an option. So to turn it into a result, first I have to say context, and we gotta say failed to find codec, failed to find video codec. Actually, it's not decoder, video codec. Yeah, okay, let's go. Nice. So what's next? So now that we have found the video codec, what's next? Allocate a codec context for the decoder. Okay. And for whichever reason, yeah, this C code is very weird. But let's see if this actually works, by the way. Oh, great. So it all worked. Nice. Let me see where is this is variable. So I have to go up to the start of the program to find out what is this. Dic context. What is even that? It's a AV codec context. Ah, I see. I see. All right. Anyway, so let's say codec context. I think. Is it? So video codec context, AV codec alloc context 3, codec context, great. And here we gotta say const AV codec. Okay, so let's give it the video codec that we have found. Nice. And there you go. Great. Great, great, great. And this video codec. Alright. Now, alloc context, what happens? Then we check if it have failed to allocate the codec context. Yep. Alright, so let's say as mute dot in wrap. Well, not in wrap. Let's say dot context failed to allocate video codec context, and let's do this, and there you go. Now we got a video codec context. Great. And up till now there's no error, I think. Yep, hopefully. AV codec alloc context 3. Next step, we gotta copy the codec parameters from input stream to output codec context. Copy the codec parameters from input stream, and if ret is equal to that less than 0, then we have an error. Okay. Great. So basically right now we have allocated the video context, but we still, there's hold on a second. Alloc context deck, then parameter. Oh yeah. So right now this context right here is linked to the video codec, yeah, because we use it to allocate, right? But until now we haven't used really the video stream here. We haven't really kind of mashed them together, or anyways, let's see how we can do this. AV codec, well, search, and it should be greater than or equal to 0. So assert that video or AV codec parameters to context. And here we gotta give it the video codec context. Okay, and then here the parameters, AV codec parameters, which we can get from the video stream. There you go, codec bar. And there should be greater than or equal to 0, I think. Yep. And this should do the trick too. Up until now we have no error. Great. And next up, finally, we're gonna initialize a decoder by opening it. Great. So kind of here we kind of like allocated the context. Here we have kind of initialized it. Well, not initialize it, but I guess prepare it to be initialized. But right now we gotta initialize it, kind of. So yeah, all right. So this should be greater than or equal to 0 to assert that AV codec open to. Here we gotta give it the codec context, right? And then we gotta give it the codec. Then we gotta give it the options, which is in our case null. Oops, null mute. And this should be greater than or equal to 0. Great, nice, 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 nice. Now we should be opening the decoder or the codec, or whichever you want to call it. Great, nice, 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 nice. And then stream index. Okay, so we have finished that function that they call open codec context. Great. Let's go to the next. Though I've done it inline for simplicity's sake. Right. And let's see. Though here in the example they're doing both audio and video, but for me I'm just doing video. So at least for now, greater than or equal to 0. Video stream, blah blah blah. Okay, so right now we need to create a file which we can basically write to it the raw video that we have decoded, right? So we have a video MP4 and we want to basically spit out like a raw video, essentially. I'm not sure which extension it should be, honestly. I think raw, maybe? Possibly. We'll see. Okay, let's see. Alright, let me open a new window here. Alright, so what we want, yeah, raw video extension. And oh, I forgot about the chat. Hold on a second. There you go. Okay. Raw video extension. Video file format. UV, I guess. Seems like, yeah. .uv. Yep, .uv. Okay, great. So let's go with that. Let's open a file. Though here I'm not sure if I'd like to use the C file or the Rust file, but honestly for simplicity and just to make sure that at least it works, first of all, I'm just gonna go, I guess, with the C file, maybe. Gonna try, I guess. I guess libc, maybe. Is it libc? Yeah, how do you open a file? In C, let's see. Where I was though, hold on. If open video. Okay, if open. Great. Great. File name. So the file name would be video dst file name. And oh, you write in binary. Okay. Video dst file name. Alright, so where's the file name again? There you go. Let's say let destination file name is equal to C. Honestly, instead of source file name, let's say input file name. That makes more sense to me. Output file name. And here, let's say cser from bytes with null inject. B, and let's see. How are we gonna do this? Let's say, I don't know, res/video.uv, I guess, for now. And of course, let's not forget about the null byte. This is a C string. And I guess that's it. And something is wrong with this. Yeah, oh yeah, let's go. Right, now if open video, alright, so output file name, .asptr of course, and then wb. Can I just do this? No, I can't. Okay. What if I say cser from bytes with null, wb, with null inject. As ptr. And there you go. So now we have opened the file. And of course we gotta check if that file could be opened or not. And by how we're gonna do that? Well, as mute dot context couldn't open destination. I couldn't open output file. Output video file. Or let's just say output file, okay. Output file. Great. Very great. Now what's next? We got a file now. Let's make sure that this works, or this works. And yeah. Now we gotta allocate an image where the decoded image will be put. Allocate an image where, so AV image alloc. Alright, so we gotta allocate an image where we're gonna put the decoded data, I guess. Alright, let's see how we can do this. Ret, less than 0. Okay, so assert that AV image alloc pointers. Here we got the video DST data, which is in our case, where's video DST data though? Is equal to null. Interesting. But why pass it if it's null? Interesting. Well, can't I just pass in null here then? It's very hard to kind of like follow with C code. It's everywhere. Okay, video DST data. It's an array for, why 4? 4 bytes for some reason that are null. Oh, could it be the RGBA basically or something like that? Maybe. But anyway, let's just do it, I guess. Or honestly, in this case, it just seems to me that null mute is fine. In this case. Okay, what's next? Video DST line size, what is that? AV image copy. It seems to be initialized. Yeah, I guess this AV image alloc would actually gives us that. Because it's mutable basically. Hold on. Okay, so it's actually maybe, yeah, it's gonna give us the pointer. Yeah, it's gonna give us the pointer, my bad. Because this just gives us back a error code. Yeah, I see now. Yep. I forgot about C output pointers, I guess. Video data, I guess. Video destination data. Or else it doesn't make sense. Let's say decoded image data, okay, is equal to null. And what it is a static int 4. How I'm gonna even describe that to Rust? Int video DST line size 4. Oh, not that. Int 8 T4. Okay. Weird. So what this guy needs? Mute UH. Okay. So this is good, but instead of mute UH, I actually want UH4. How I'm gonna do this? I think like this in Rust. I guess so. Mutable UH4. Yep, seems like to me. And here it's probably not gonna accept it actually. I don't know. Seems to be a hold on. Decoded image data here. And in fact, let me go back here. Video DST data, not here. Okay, video DST data. All right. So what's next? Line sizes. All right. Decoded image line sizes is equal to, it should be also null, I guess. Actually, this one is initialized, I believe. Video DST line size 4. It's an int. Okay, so basically it is an array of 4 ints. Okay. An array of 4 ints. C int, yeah? Yep. 4. Is it this way though? No, I don't think. Yeah, I think here you give it the default value, right? Can I say C int here? No. Okay, what about C int? Well, from 0, I guess. Yep, okay. Alright, and then here I'd like to basically pass it that line size is mutable C int. Okay, and right, let's go. Video DST, line size, decoded image, line sizes. And here I could just say as PTR, I think. And what's next? Width. So the width comes from the video decoder context. Okay. Video codec context dot width. Video codec context dot height. And pix FMT, I believe, same thing. Yep. And finally 1 for the alignment. Yep. And what's else? Expected mute UH but found mutable UH4. And expected mute cint found oh yeah, as mute pointer. There you go. But shouldn't then be like, shouldn't this be immutable then? Weird. Anyways, type mismatch expected mutable but found mutable UH4. Okay, well, how am I gonna fix this? I need to turn the alright, so no. Let's bring in Copilot, I guess. How to convert mutable, well, yeah, mutable UH 4 to mutable UH. All right. Alright, so you got the array pointer and then the UHPTR, then UHPTR, as mutable. Decoded image there. Oh, I guess I could easily do that actually. Hold on. What if I said as mute UH? Would this work? Yeah, nice. Great. So, alright. And cannot borrow decoded image line sizes as mutable. It's not declared. Yeah, that's what I was thinking. It was weird that it didn't error, but it seems like it just didn't catch that error until I fixed that one. Alright, there you go. This should do the trick, I guess. Hopefully we don't get any sick fault right now. This is crazy stuff. Right. If red less than 0, now allocate raw video buffer. Huh. That a video buffer? What? But anyway, video DST buff size. Ooh, it gives us the buffer size. Huh. I see. So this is the the decoded image data size, actually. and then we could basically assert that it's greater than or equal to 0. And there you go. Great. Great. Let's see if this even works without a segfault. Alright, I knew it, bro. Let's go, we got a segfault. I knew it. I didn't know why, but I knew it's coming from all of this craziness we're doing here. Anyways, so why that happens? Fault address 0x0. Why? So it's saying something is null. I mean, yeah, this is null, but like it needs to be null. Yes, I don't know. Let me see this weird code that is happening here again. What it's calling it. Video DST data. Oh, I see. Well, in C, it's not saying null, that is equal to null, but it's basically initializing. Oh, it's initializing an array that is an array of pointers, 2 bytes. I see. Right, gotcha. Makes sense now. So it's probably maybe like it's like an array of 4 elements, and those 4 elements are basically arrays. So like a 2-dimensional array of 4 elements. But anyways, I think I gotcha. Okay, let's see how we can do this. So I think my signature is wrong in the first place, correct? Yeah, it is. Because we essentially want an array of mutable UH. Okay. Yep. Is that the case? Yes, I think so. And now here, what we're gonna do is, in fact, I don't even need this anymore. I could just say this, and here I could say null. Not sure if it's gonna be non-mute or what, probably 4, but it needs to know, I guess, the type. Oops, U8. Does that work? Yeah. Is it the other way around, maybe? Nah. How do you do it then? Oh, I see. Alright, so that's how it's supposed to be, actually. I didn't see the C code clearly. Alright, so what's happening here? Well, now it's kind of changes though. Right now it's going to be as mutable, basically. As mutable pointer. Is it? Yeah, great. And now it's going to be mutable. Great. Not sure if this should be null mute actually. Yeah, it should. Great. So I think this shouldn't make a sigfold now, hopefully. There you go, nice. Yeah, I just instinctively knew that there was gonna be a sigfold for whichever reason. Because there was just a lot of pointers going on. I knew I'm gonna make a error. Anyways, so whatever. We have fixed it. Great. What's next? Let's go. So after allocating the data, what you do? Dump information to std error. Okay. Alright, how am I gonna do this? AV dump format, format context, 0 to the index, and here source file name, input file name, .sptr. I could probably actually turn that into a pointer directly, maybe, but anyways, whatever, fine. And is output, just say 0, and there you go. Alrighty, let's see the output we get here. And alright, that's correct, I think. Input 0, move from rest video. Okay, creation time, duration. Yep, that's correct. Great. It is H.264, the stream, yeah. And UV. Alrighty. I'm back, welcome back. And we're already creating the file, but of course right now it contains nothing. Right, audio ISO media file produced by Google. Alright, nice, that's correct. Matches greatly what I have here, because if I say this, media info video .mp4, I'm gonna get the same exact thing. We got the first video stream is ID1 and AVC, which is like H.264 encoding, and UV, stuff like that. Second stream is actually AAC, Advanced Audio Codec, which is correct. Great. Let's go further. So now we got the dump format. What's next? For now, audio stream and no video stream. Could not find audio or video stream. Okay, what's next? Alright, right now we gotta actually allocate a frame. We don't need this anymore, honestly. Fine. And let's go. So now what we need is the frame. So AV frame alloc. AV frame alloc, and let's say as mutable. Dot context. Failed to allocate frame. And there you go. That's the frame. Nice. Next, packet. AV packet alloc. As mute. Context. Failed to allocate packet. Let's go. Great. Right. What's next? If video stream, demuxing video from file. Into I see, okay. Now read frames from the file. Alright. While AV read frame format context packet greater than or equal to 0, check if the packet belongs to a stream we are interested in, otherwise skip it. Great. So if packet stream index equal video stream index, then decode the packet. Else if that, then decode the packet, and AV packet in ref packet. If ret less than 0, break. Pretty cool stuff. Flush the decoders. And the demuxing succeeded. Ooh. I think we're quite... Alright, fine. So let's start getting some frames. So while AV read frame, format context, and the packet. Right, greater than or equal to 0. Then what we do. So while AV read frame greater than or equal to 0. So if packet, and hold on a second. Yeah, that's fine. Pyre, welcome to the live stream. Have you been doing your Advent of Code? I don't honestly enjoy Advent of Code. I never tried it, but I don't see like the I don't like such puzzles like where I have to read a whole wall of text and try to figure out then. I just like if you have a problem, like some sort of puzzle or something, just give me the problem directly. I don't like to read like a whole wall of text just to understand what's the problem and then try to resolve it essentially. So yeah. The input and output. Yeah, exactly. Just tell me what is the input and what do you want to output like. That's otherwise just give me a real world problem instead of just an imaginary problem that I have to solve. But yeah, pretty much. So if packet stream index is equal to video stream index. Where's the video stream index now? Oh, video stream. Well, there's ID and there's index, yeah. And there you go. So if it's video index, then we're gonna do our stuff with it. Otherwise, we're just gonna ignore it. And oh, interestingly, you say AV packet in ref for whatever reason. Wipe the packet in reference the buffer referenced by the packet and reset the remaining packet fields to the default values. Interesting. So if we don't care about it, we just inref it. So yeah. Packet. If ret less than 0, break. Which ret are you talking about though? Oh, I see. Rich. Alright, so essentially decode. So basically if something happens wrong, then we're gonna equal 0. So okay, so here they have an actual like separate function called decode packet, but honestly, again, just for the sake of simplicity, I'm not gonna bother with that. I'm just gonna go directly and just inline that decode packet function here. And basically that decode packet in the case when it's a video stream, we're going with decode packet and we're giving it the video decoder, right, context and the packet. On the other hand, if it's audio, we give it the audio decoder context, but whatever. Right now we don't care about audio, we only care about video. Great, so let's check the decode packet function. There you go. Okay, great. So what we should do here, submit the packet to the decoder. So let's do that. And if ret less than 0, then return ret. Okay. So let's go ahead and do this. So if not, actually what I'm gonna do, I think, well, what you do when it's you just inref it, right? I guess I'm gonna do the reverse honestly here. AV packet in ref of ret less than 0. But what ret is by default though? Very hard to find. But I guess what's gonna happen is if it's not something we care about, if it's not a packet we care about, we're just gonna inref it and we're gonna go forward. Continue to the next iteration, to the next packet. And here right now we could decode our video packet. Great. So let's go ahead and do this. Let's go. Alright, where's the function again? Decode packet. Great. Alright. So now let's send the packet to the decoder. Right. And honestly, I'd like to... Well, fine. Anyway, let's just go ahead and say AV codec sent packet. If it's less than 0, what happens if it's less than 0? Here it's just returning it and printing the error, but like, and then what's next? Oh, it's actually inrefing the packet in both cases. Like, hold on. Yeah, seems like it. Ref less than 0 break. Okay, let's say AV packet in ref. In fact, this seems to be not just for weird. Fine. Let's say this. Yeah. Well, else than nothing, really, I think. Right, yeah, this should be good to go. I think. Yeah, let's go, fine. The C code is very hard to follow. It just goes everywhere. And especially, it's not modern C even. It's not even written in modern C. It's written in, like, C of the rock, the Stone Age. So, anyways. Alright, now let's say assert, assert that AV codec send packet context packet that it's greater than or equal to 0. Hold on. If ret less than 0. Okay. And just like that, we send the packet to the decoder. What's next? But hold on. Yeah, fine. What's next? Get all available frames from the decoder. While ret greater than or equal to 0, ret AV codec receive frame, decoder frame. If ret less than 0, interesting. So basically, you call AV codec receive frame, then it gives you a return code. So while return, yeah, let's just do it as it is there. So I guess let's call this, I don't know, return code is equal to 0 or whatever, while ret return code greater or equal to 0. Oops. And there you go. Now ret, essentially what they're saying is that return code is equal to AV codec receive frame. the decoder. Yeah, video codec context. And then the frame. And honestly, instead of doing it this way, fine, whatever. Okay, so this should be mutable. If ret less than 0, then there is two cases. If it's equal to AV error AF, or it's equal to AV error A again, then we're gonna return 0. What? Otherwise, we return ret, error during decoding. Okay, so let's see. So if return code is equal to AV error AF, oops, or return code is equal to AV error A again, then we gotta return 0. But in our case, we don't have a function, so let's see again. I don't remember how they deal with the. Hold on, let me see. Ret is equal to, and if it's less than break. Okay, so if that happens, then yeah, fine. Like, because here we're just saying if ret less than 0 breaks, so like when an error happens. But if it's equal to 0, fine, who cares? Okay, great. Return 0. So essentially what I should say is a search but hold on, return yeah, we actually should go off this while loop, right? Because we're returning. Yes. So in this case, we gotta break, I believe. Break the inner loop. So we go to the next packet, which honestly doesn't make too much sense to me, I guess. But anyways, whatever. Otherwise, a search that return code is greater than or equal to 0. Right? Assert that return code is greater than or equal to 0. AV error to stir. Oh, that's interesting, honestly. Greater than. But hold on. Yeah, it's very weird, honestly. It's very weird. But essentially, let me just do it as they're doing it exactly, because this is super weird thing they're doing there. So I'm probably gonna get it wrong. So if return code is less than 0, what they're doing is if ret equal AV error AF or that, then in our case we're gonna break, and then otherwise, then we're gonna essentially if print if AV error to string. Well, then we're gonna panic actually. In our case, panic error during decoding, huh? So error during decoding. Let's see. Well, not like this. And how are we gonna do this? Error during decoding. Yeah, I think. And then what we're gonna do is we're gonna give it AV error to stir. There's no error to stir here though. I guess it's a custom function then. Maybe. Huh. Weird. Error submitting. Yeah. I don't know why we don't have it. Cannot find value in this scope. Yeah, we don't have that. Well, anyways, we're just gonna, I guess, panic. Error during decoding. Oops. I'm just gonna give it the error return code, basically. That's it. Okay, what's next now? So write the frame data to output file. Finally. Write the frame data to output file. So now, after this, if codec, I guess, video codec context probably, dot codec dot type. Well, in our case, we already know our codec that we're working with here. So right now we're just gonna output video frame, correct? Else, and then AV frame in ref. So let's see what this function does. Output video frame. Alrighty. So right now we're gonna be outputting to the file. Okay, there's some crazy stuff here, I guess. Yeah, it's fine actually. Yeah. All right. Error with height and pixel format have to be constant in a raw video file. Weird. To handle this change, one could call AV image alloc again and decode the following frames into another raw video file. Error with height and pixel format have to be constant in a raw video file, but the width, height, or pixel format of the input video changed. Alright, I see what they're saying. I don't think that would happen in our case, but just to be safe, I guess. Alright, so here what we're gonna say is we're gonna assert that frame width. Oops. Frame width is equal to, actually not equal to, width. Which width are you talking about though? What? Where the width is coming from? I see, it's a global variable. Where this global variable is being set again? That I hate the global variables after this. You don't, like, when you're working with a global variable, you never know where things come from. Like the control flow just goes crazy. Allocate the image where the decoded image will be put. Okay, height. I see. So yeah, it's basically the video codec, I guess, stream context, right? The width essentially. And or actually, well, hold on. Okay, let's go back now. So if frame not equal to width, actually we should basically make sure that it's equal, and that frame dot height is equal to video codec context height height equal, and format it also should be equal. And frame dot format should also be equal. Where is format? See it? What? Oh yeah, I see. And then it should be equal to video codec context to dot format. Get format? What do you mean? Video codec context. Where we're getting the format? FFMPEG. Let's see. Well, from the context. So what's up with this guy? Oh, it's called FFMPEG. Okay. So in the frame it's called format, and in the codec context it's called FFMPEG. Great. Great. Yep, exactly. But it's super consistent that in FFMPEG it's AV pixel format, and in the format it's I32. Great. Alright. So I'm gonna do this. Well, let's try this one. Can we do this? No, we cannot. Okay. Then I guess let's do the reverse then. Yeah, the reverse we can. Great. So what's next? So now this is just an assert to make sure everything is fine. And then here we got some video frame counts. And yeah, right now we copy the decoded frame to the destination buffer. This is required since raw video expects non-aligned data. So I guess image is maybe aligned basically, but it's actual data but aligned. Anyways, let's see. So AV image, what's happened here? Oh yeah, AV image copy to. There's no copy to though. Weird. Here we go again. Copy to buffer. Copy. Well, let's go with this one. Destination data. I called it output data, I think, or like the decoded data. Yeah, called it the decoded image data essentially. The one thing that I'd like to do, but fine. Anyways, let's just go with this. Decoded image data, I think, and then the line sizes, and then the frame data, and then the frame line size, and then the FFMPEG, which is the video codec context FFMPEG, and then the width. A lot of redundant information. Video codec context height. Right, cool. And yeah, let's see now what's wrong with all those type stuff. Type mismatch, expected const mute but found mute 4. Okay, too simple, I guess. As const mute what is that? Oops. Non-primitive cast. What about dot as PTR? There you go. What about this one then? Exactly, nice. But found, so expected const but found that const. Mismatch expected const but found const mute. What? Well, it should be fine then. Expected const mute found const mute. Wait. Okay. Some things really seem like the compiler just yelling at me. But anyways. Type mismatch expected const libc unix cint but found the cint h. Oops, as PTR. There you go. Great. Alright, what's next now? We have copied the image. Now we use fwrite. Write to raw video file. Fwrite video dst data. The pointer is video, well, decoded image data, I think. 0 for some reason. I guess it's maybe because of, maybe it's UV and then like it gets the the Y only. Anyways, whatever. We'll see. Anyway, I have no clue what I'm talking about. Video destination buff size. What's that? Oh yeah, I think. Yeah, I see. Decoded image data size, I believe. And what's next? The video DST file. So the output file. Right. And now what's going on here? So time mismatch expected const C void. Found mutable UH. Expected CU long, but found C int. Okay, great. We have finished the decoding. Let's go to the next step. Now we gotta flush the decoders. Yep, that's the only step we have left. So after the loop, we have to make sure to say, ooh, hold on, flush the decoders, decode packet null. What is that? Oh, instead of giving it packet right now, it's doing all that with null. What is that? Go back. Let's see decode package. And then what happens if it's null? Send packet. Is there like codec flush? This seems just to be so badly designed. Weird. Oh well. Flush the buffers. Hopefully this would work. I don't want to do that stupid stuff they're doing there. Reg. And what else now? AV codec. Send package. What else? Alright, so I think right now we're just gonna close the file and that's it. How do you close a file in C? If close? Seems like. I just want to close it just to make sure. And there you go. Let's see what's gonna happen. So it's going, I guess. It's doing the job. Okay, hopefully it wouldn't destroy like my computer. Uh-oh. 8 gigs, what? Bro, yeah. 10 gigs. I don't think I have enough memory for that, bro. Oh, no, stop it, bro. What? I don't think this would be good. How much memory still have? That is crazy. 16 gigs now. 18 gigs. No, stop it, bro. That's, I don't wanna fill my whole thing. 4 gigs free. No way. Let me grab some smaller video. This is crazy. Yeah, let me grab some smaller video. Well, yeah, I need some smaller video because that's crazy. 16 gigs already, and I don't know even how much was left. Yeah, let me try to find some small video real quick somewhere. That was crazy. Alright, let's see videos, because it's basically decoded video, like no compression done at all, like raw. Alright, let's see, videos or what? Pictures. Yeah, I have this little video right here. Yes, let's put it in res. And hopefully this would be small. Alright, let's see. Let's go. There you go, it's done. Oh my god, let's go. How big is that? That's 1.9 gig. From 47 megs to 1.9 gig. Ah, crazy. Crazy. Alright, so let's say FFplay res/video .uv. What are you talking about? What is this? Bruh, don't tell me this doesn't work. Like, what? Oh my god, why this is open it in it? Ah, that's crazy. Yeah, I've just opened 1.9 gigs in a test program, in a text program. Well, let me try VLC. Bro, what's going on? I've just created a Pac-Man game or something, or what? What is going on here? This is weird. Invalid argument. Okay, let's see. Let's see what they said. Hold on a second. FFplay. Oh, I see. I need some few things actually. So FFplay res/video mp4 OL-F. Alright. Oh, dash pix fmt. I see. Oh well, let's just cheat a bit, I guess. Let's see. Let's say FFF probe, I guess maybe video mp4, and let's grab the pix fmt from there maybe. No such file. Okay. Right. So what is it? The video? It's UV, I believe. UV 200. So it's basically the raw video just contains the frames, but like they have no idea what is the size, what is the format or whatever. It just contains raw frames. Okay. So let's grab this copy and let's see what we could do here. FFprobe, no, FFplay dash f oopsies dash f here dash pix fmt oh, let me paste this and dash video size, and there's X. Oh, I see. So let's see here. So what kind of size is that? Oh yeah, 1000/20. Yep, I think so. What? A known input format. Yeah, let's remove that UV. Because it doesn't seem like the right extension. The right extension is just not do anything. What? Unknown input format still. Weird. Okay, did I miss anything here? Dash F rest slash video dash pix FMT dash video size. All right, let me do something here. Maybe the format is wrong. Let's say yeah, let's say here or whatever, like a video codec context AV get pix FMT name, and here video codec context pix FMT, and what is that? Yeah, it gives us a const C string. So let's say C string. Huh. What? The variable may be initialized. What? Expected mutable cchar. But why it should be mutable? Weird. Oh. Weird. Let's see. Hold on. What about new though? From what? What about Caesar? Name. There you go. We got at least a Caesar. Great. And then hopefully we could turn that into a string or something. Let's see. Print line. There you go, it's UV 420p. UV 420p. A known input format. Super weird. Well, failed to set value rest slash video for option F. What? For option not found. What? Let me see for FF play help. Bruh. Grep. Okay. Set output pixel format. Okay, let's try something. What about dash format? Bruh, what? Invalid data found when processing input. Well, this is crazy. Now I'm not sure if I don't know how to use FF Play to run like raw video files, or what exactly is going on here. There you go. Demux. Packetizer. What? crazy stuff. So if I say video, cannot open file. Oh yeah. What about if I say dash row vid dash row vid dash width? A 20, I guess. Dash row fit dash height 80. Bruh. Okay, what about the format? How can I give it that? Use carefully. Dash demux. Row vid. Bruh. Come on. VLC raw video format. Bro, let's try to do something, I guess. Okay, so media open file, huh? Nah. App open capture device. Application from keyboard, clipboard. Let's try this one. And bro, what you want to do with VLC? Not GIBD. Welcome to the stream. I want to see how can I have this raw video format, like this video is contains all the decoded frames from the MP4. Now I need some way to play that, like in the example that FFMPEG have. They use FFplay, which I tried, but it didn't work for, I don't know what the reason is. Now, what I'm not sure about right now is, did I miss something when I was implementing this, or is it I don't know how to play a raw video? Because raw video doesn't contain a width, doesn't contain a height, doesn't contain a format. You have to give it to the player, which in this case is VLC or FFplay. FFplay, I tried to give it that, but it still failed for whichever reason. So right now I'm trying to do that with VLC basically. Res video, huh? There you go. Use the subtitle file, show more options. Start time, stop time. No clue. Let's try to, I guess, convert. display the output. What? This doesn't really seem like what I want. Bruh. The interlace dump. H264. No. Okay. And no. Yep, no idea, honestly. So we have decoded it, but no clue what's happening there. Maybe I need some hex edit or something to maybe try to see what's happening there. Hex dump video. Oopsies. Alright, well. There's a lot of 2Bs though. Interesting. Bruh. What else we could try? Bro, why this blocked? Great. Oh, what the? Less than 1 megabyte is left on the system directory. Are you kidding me? Bruh. Oh. Oh. Maybe I know. Is the stream fine though? Is the stream fine? That's crazy, man. How did I fill my whole disk? 4.3 gigs free. Is the stream fine? Alright, fine. That's crazy. I have no clue how that happened. I just filled my whole disk. What? I need to remove something. Oh well. No clue. I guess I had like 20 gigs free or even more. I don't know. I don't remember. And suddenly, just like, bruh. No clue. Rust projects, 44 gigs. uh, yeah, let me remove some Rust projects. Interesting. I have a second disk, but I'm not using just yet, so. Where is Rust Rover? I don't know which one is taking the most though. Hold on. Go back. Scan home. Bevy. Bevy, 16 gigs. What? Okay. Bevy is crazy. Alright, let me remove the Bevy project, I guess. I don't know if I have anything interesting there though. Yeah, not really, so I can remove that. Right, I should free us some memory, I guess. At least for now. How do you... Yeah, let me empty the trash. Right, there you go. Okay, so great. Alright, we got 15 gigs, 50 gigs right now. That was crazy. That was another level. Okay. Alright, so as I said, I think I found possibly maybe the problem. Actually, I don't know. But let's see. Let's just remove this. And I guess let's try again. Okay. $19.20. Yeah, invalid data found when processing input. That doesn't tell me much. Honestly, one thing that I skipped actually, which is flushing the codec stuff. So I guess let's try that, and hopefully that would fix it. Though. Well, okay, fine. Fine. Right, let's see. While AV read frame and then the code packet, other than AV packet in ref. Okay, so this whole code right here. Well, not really all of it, but yeah, up to here, I think. Yes. Okay, so let's grab this. Let's call it decode packet, where we're gonna pass it video codec context and then the packet. And that's it for that one. And here, instead of flush buffers, I'm just gonna say decode packet video codec context null. And then we're gonna create this function, and the first parameter would be the video codec context. Oops. And then the second one would be the packet. There you go. Alright, so what is here? AV package. And let's just grab this guy here. Alright, let's call this an unsafe function, I guess. And I need the decoded image data, the frame, blah blah blah. Interesting. Come on. Alright, fine. Where's the frame? Where is the frame? There you go. Mutable AV frame. Okay. Alright. And they need the decoded image data. Line sizes, output file, blah blah blah, you name it. Right. Actually, hold on. Right, decode package. Right. Yeah, okay. So actually, hold on a second. Oh yeah, I see the decode packet. Like, yeah, that code uses global variables, that's why. Alright, fine. So the decoded image data is this guy, mutable UH4. The decoded image data is mutable UH4. Oh yeah, and then here too. This function takes 4. Oh yeah, frame here. On next. And then we need the decoded image line sizes and data size. And what is the size? Int. Okay, that's the decoded image data size. What's next? The decoded image line sizes. And for that we need int 4. Honestly, probably not gonna go that way, really. I'm gonna pass the row pointers, I think. Yeah, that's what I'm gonna do. But anyway, and here we need the output file. And for the output file, we need where we're opening the file, mutable file. And there you go. Right, now we need to pass in all of that. Okay. Same thing here. Except for this one. Okay. What's next? Seems good to me, but honestly, instead of doing like this and this, I would honestly just pass them as a row pointer for now. Row pointers directly. So just to avoid any stupid problems for now. And expected const libc int. Okay. What is that? Image line sizes. Const. What else? And the decoded image data. There you go. And now as PTR. Rich, what else? Here. Okay, did I miss anything else? Let's see. As PTR. The frame stuff is fine. And yeah, I think that's maybe it. Okay. still same problem. Right, so yeah, I followed exactly what the tutorial is doing down to the T, but it just doesn't work. Though let's try to do something. I'm gonna copy this into a C file and let's see if it actually really work. And just to make sure it's not on me. Alright, let's just FFMPEG, well, C. Okay. Labels. Okay. Indefined reference, indefined reference, indefined reference. C make lists. Oh my god, I didn't see this for a long time. Alright, target. There, that's what I'm talking about. Copilot doing the job. That's nice. Nice, nice. It works. Right. So input file, output file, audio output file. Okay. Input file gonna be, well, let me grab the input file. Video MP4, and there you go. And let's see. So the input file is video MP4. Oops, not here. Program arguments video .mp4, and then the video output file. And for that output file, video, and then the audio output file. I guess we're gonna call it audio. Okay. Let's try. Could not open source file video MP4. Why? Why not? Weird. Let's say the working directory is this. Or you know what? Let me do this. We're gonna copy location. And yeah, let's just do this actually, and let's say this apply. Okay, there you go. And let's see if this even works. If it works, then I am doing something wrong, or something like that. Oh, -F raw video. Oh. Okay. What? Option not found. Are you kidding? But I did find it, I guess. Format, dash format. Let's try to change that to dash format then. What? Alright. This is crazy. Option not found. Okay, let's see. FF play. The Pix FMT. Option not found. What? I don't know. Weird. Now, I don't understand if this is like that Pix FMT is not found or... Let's see something. Okay, option not found. So it is Pix FMT that is not found. Okay. Okay, what if I said format what? Oh my god. What? How am I able to set this then? Bruh. That's crazy. This doesn't make any stupid sense. Okay. Right now it's called pixel format. Let's go. Nice. Ah, that was crazy. Alright, so this actually work with the FFMPEG program. But yeah, the example itself is also outdated. The official example in terms of the ffplay command. So let's try it right now with our video. That's crazy. Raw video. No such file directory. What are you talking about? Oh yeah, rest/video. It works. Oh my god. Ah, that's crazy. Next level. Finally. That was crazy. Yeah, it works perfectly. There you go. Nice. Nice, nice, nice. So we have decoded the video MP4 H.264 into raw video format, and we have played it using FFplay. So you say -F raw video. I think that's the dash format or something, I don't know. And then -pixel format instead of PixFMT. PixFMT doesn't seem to work anymore. UV 420p dash video size 1920 x 1080. And then the file name res/video. And there you go. Oh my god, that was crazy. That was the next level. Bruh. And honestly, what happens when you flush the thing? Come on. There you go. It receives a frame. Then it copies. And then it actually writes. Oh, I see. Yeah, you gotta flush. It may actually write something to the file. I see. Alright, anyway, never mind. That's good. Good. Though I'm gonna run it just to make sure that the video is still fine now, because I probably corrupted it with that. Alright, so what we should do next? What do you guys think? Right, we have done it. Alright. Yeah, I'd like next to basically clean this up and try to use more rusty stuff, and possibly abstract it, etc. Yeah, I think honestly, how much time we've been streaming? 2 hours and a half. Yeah, I think I'm gonna stop the stream for now, I think, as a milestone. And yeah, though I'm gonna save this command too, because I don't want to guess it. Like, let's see, copy, and I'm just gonna put it here. Command dot sh, or actually play dot sh. There you go. Now chmod +x play.sh, or just play. Yeah, we could just say rename play, and here bang /bang/sh or bash or whichever. I guess maybe let's go with bash, and let's go. Now, there you go. Nice. Yeah, I guess maybe next we'd probably use SDL or Raylib or something to actually display the play the video or something. But we'll see how it goes. Either way, I think for now, that's it for this video. I have 2 GPUs. How to use both in the web GPU. Ooh, 2 GPUs. I don't know honestly about web GPU. I know about Vulkan. a bit, but for web GPU, no clue how we would do that. I don't know like if they support it. And even either way, it's gonna be pretty crazy. And I don't know. I don't think like you can exploit two GPUs very well. I don't know. But anyways, whatever. So that was it for this live stream. Thank you everyone for tuning in, and see you later. Goodbye everyone.